Sometimes you'll have data on two categorical variables, and the easiest way to organize your data will be in a two-way table. So a two-way table will contain data on two categorical variables. And one variable will define the columns of the table, and the other variable will define the rows of the table. Here's an example from the Titanic again. We have classes, first, second, third, and crew, of the people who are on board the ship, and class, therefore, is the row variable because the categories of class define each of the rows in the table. And then survival up here, whether people survived the sinking of the Titanic or not. That has two categories, yes and no. And the yes column represents the people who survived, and the no column represents the people who did not survive. And survival is the column variable because it defines the categories in the that define each column in the table. And then each of these numbers in here represents a joint occurrence of two categories, one category from the row variable, one category from the column variable. For instance, this 202 right here represents first-class passengers who survived. This 167 represents second-class passengers who did not survive, etc. Now, sometimes when you're given a table like this, you want to know, well, how many people were there in first class altogether, or in second class, or third, or crew? And what you do there is you just total up across the rows. And when you get those row totals, you can see these are the same totals that you saw in the preceding video. You get the marginal distribution of that row variable. So the row totals make up the marginal distribution of class in this case. 325 first-class passengers, 285 second-class passengers, 706 third-class passengers, and 885 crew. So the marginal distribution of the row variable consists of the row totals. If you want to form the marginal distribution of the column variable, you just form the column totals. So you add down the columns. We had a total of 710 survivors and 1,491 people on board who did not survive. This is the marginal distribution of survival. The marginal distribution of the column variable consists of the column totals. Okay, and then you have a total of 2,201 people on board. That is the total of these row totals, and it's also the total of these column totals. And if those totals don't agree, if you add down this way and add across that way and you have a discrepancy, well, there's a problem. Go back and check your arithmetic. Now, what we often want to do when we see a two-way table like this is to see if there is any kind of an association between the two categorical variables that are in the table. And the way to do that is to look at distributions of counts on one variable for a given category of the other variable. And when you do that, you're forming a conditional distribution. So let's look at that in more detail. Conditional distributions are formed by the counts in one row or column. So we say, okay, we're going to just look at people who survived, for instance, and we want to see how class of the people on board is distributed in that particular column. So the column, in that case, forms a condition. We want to see how class is distributed among the survivors. And you might see this kind of notation a lot. I know you'll see it later on when we do probability. This little line in here means if or given. So this is class if survived, or class given that someone survived. Okay, so we have a conditional distribution of class among the survivors. And all this is the counts from the column of survivors. That's all that is. So we just basically took the left column of the table here and we copied those counts out. And then if we want to see how these are distributed as a percentage of the total of the survivors, what we do is we divide each of these counts by 710, the column total, and then we multiply by 100%. So 28.5% of the survivors were in first class, 16.6% of the survivors were in second class, 25.1% of the survivors were in third class, and 29.9% of the survivors were among the crew. And these percents right here total up to 100.1%. That slight discrepancy from 100% is just because of rounding error. That's all it is. Now we can do the same thing with the column of people who didn't survive, and we can get a conditional distribution. based on that. Okay, so we have the conditional distribution here of class among the dead. So this is class given that somebody died. And we have our 4 classes again. And these are the counts. 123 of the dead were in first class. 167 of the dead were in second class, and so on. And these are the percentages that each of these counts makes as a percentage of this column total down here. So 8.2% comes from multiplying, or dividing rather, 123 by 1,491, and then multiplying by 100%. So this is 8.2, this number right here is 8.2% of that total. This number right here is 11.2% of that total. This number right here is 35.4% of that column total, and the 673 is 45.1% of this column total. And these percentages add up to 99.9%. Again, due to rounding error, it's not going to always come out perfectly to 100%. Now, if we want to see if there is perhaps a difference in these distributions, this conditional distribution of class among the survivors versus the conditional distribution of class among the dead, we can make 2 segmented bar graphs, one for each distribution, and then we can put them side by side, and we can see how these distributions compare. So I've done that on this particular graph. Here we have class of people on the Titanic versus survival. We've got our 4 classes, first, second, third, and crew. Down here we have survival yes, survival no. And again, as before, we have a scale that goes from 0% to 100%. And then we have our bars that run all the way up to 100% in both groups, the people who survived and the people who didn't. And then we break up each of these bars into segments according to the percentage in each class within that bar. So right here we've got the first class, the percentage of the survivors who were in first class, second class, third class, and crew. And here we have the percentage among the dead of first class, second class, third class, and crew. And you can see from the picture there are some pretty dramatic differences. Right here you see among the survivors there is a very high proportion of first class passengers in comparison to the proportion of first class passengers among the dead. And also you see a somewhat larger proportion of second class passengers among the survivors versus among the dead. And then the opposite is true for third class and crew. You see a larger percentage of the dead who were in third class versus the percentage of the survivors who were in third class, and a larger percentage of the dead who were crew versus the corresponding percentage among the survivors. And people have made a big deal about this for many, many years. The Titanic sank over 100 years ago, and people have been talking about this ever since. And you've seen many movies about this. This would show an association between class and survival. It looks like first-class passengers had a better chance of surviving, and crew and third-class passengers had a worse chance of surviving in this situation. People have been discussing this for decades and decades, and you got to remember when you look at these things, you see a perceived association between these variables. Always remember that there might be variables lurking in the background that are not explicit in this analysis. And one of those is that women and children had a higher chance of surviving than adult males did. And if adult males are disproportionately represented in these different categories of class, then that could be contributing to what you're seeing here. And so there might be that lurking variable of sex behind the apparent association you're seeing. So that's worth studying further if you're interested in that sort of thing. There are lots of places online where you can get data that disaggregate the living and the dead in the Titanic disaster, and into all kinds of different categories by age, sex, etc. And it's a lot of fun just to look at and investigate if perhaps you're morbidly curious about that sort of thing.